Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Pvt Limited. I have 14 years of work experience in the fields of artificial intelligence, software development and robotics. This video is part 4 for Basics of Unsupervised Machine Learning. Okay, so let's continue with the previous session. I will give you brief what we did in previous session. We were looking for unsupervised learning techniques. We have seen the clustering algorithms and now comes the part of dimension reduction techniques. So what it means and what are the techniques. First I will show you the charts that I have plotted. Okay, so let's see. First thing is these are the project files. Okay, so I will activate the virtual environment. Now let's look one by one these techniques. First is PCA. Okay, so let's see PCA. This is the chart being plotted. So what are these dots? Why we need this technique? We will see everything. So first thing I will tell you what this dimensionality reduction means. This means, so if you look at the data set or in some real world situation also, the data you will be having will be more than 2 dimension. Means in the chart you only have x and y coordinate, as you know, x and y coordinate, but the real data contains more than 2 fields. This is the real world situation. So what will you do if you want to plot a chart or see for some abnormal activity or detect fraud or anything like that in unsupervised learning? So how you will detect? So there are some techniques available to reduce the dimensions. So from these many dimensions, only 2 dimensions can be taken. You don't have to do anything manually. There are techniques available. So let's see. It reduces the dimensionality of a dataset by transforming it to a set of uncorrelated variables. Let's see the real world example. Imagine you have a lot of information about your customers. So you will be having their age, income, spending habit and many things. With all these details, it can be hard to visualize and understand patterns because there are so many features. So how you will understand? You only need 2 dimensions, then only you can compare and view the data, right? If I add too many things here, we will not be able to understand the data properly. So how to reduce the data to make sense out of it? You don't have to do manually. This is first technique, PCA. PCA is like taking all the complicated details and boiling them down to just 2 or 3 important things called principal components that still capture most of the important differences between customers. So lot of data, lot of fields, reduce them to just 2 or 3 important things. This is what PCA is doing. So this is 2D plot. Now comes the part how to read this plot. First I will show you what I have done in the code. So in this data.csv file I have data of customer, customer ID, age, annual income, spending score, cluster. These are comma separated values CSV file. So this is customer ID, this second one is age, like this you can read it. This is annual income, spending score, and this is cluster. So this is what data file is containing. Now what are dots? They are customers. These dots are customers. Each dot on the plot is a customer. The closer two dots are, the more similar the customers. Okay, so let's move this here. Okay, so closer two dots are, more similar the customers are based on the information you have. So they must be having some similar characteristics. Because of that, they are these the distance is less here. Position on axis, these are called principal components. So you cannot just say this is age, this is income. It will distribute them to two principal components. So on x-axis we have principal component 1 and y-axis principal component 2, and these are already these are being done automatically. You don't have to manually do anything. It is automatic. So how these axes were made? These two axes are made by combining the original information, age, income, etc. into just two components. More spread out the dots are on these axes, the more different the customers are. So see, this customer, this customer must be having different characteristics, and they are different, totally different. Because of this, distance is big or large. This is how you read the PCA plot. And if you have applied clustering like k-means, the colors show which customers belong to the same group. So these dots, yellow dot belongs to the same group. Dots with the same color are more similar to each other. So this yellow one, they must be having some similar characteristics. This is the reason they are being colored in same. So in yesterday's session I have told you what this clustering means and why we do it. And in this we don't have the output. The output is generated by the algorithm in supervised learning. So these looking at these charts, we can detect the abnormalities or some difference in the data, and using that data we can use that data. I told you the real world scenario, the cases. So they are being used in market analysis, document clustering, customer segmentation, genomics, social network analysis, fraud detection. So these are all the things. From the lot of data, if you want to make sense out of it, or capture the problems, then you can use these techniques. The part comes, why use PCA? Simplification. It reduces many complex features like age, income, etc. into just 2 or 3 key dimensions that are easy to plot. So what will happen is, if you have too much data, so what you will do is plot many charts on x and y axis, and then look for the relationships. This is what you do. So you have to create 10-15 charts, then analyze those charts and then make sense out of it. So using this PCA, you just have to look at this one chart and you can make sense out of it. So this will help in automation. Here I have mentioned the same thing. Without PCA, imagine you have 10 different features about customers, age, income, spending habits. Trying to look at all 10 at once would be confusing. PCA takes those 10 features and reduces them just to 2, making it possible to plot and understand the overall pattern among your customers. See, same thing in the example. So if you want to reduce the complexity, this is the first technique. Okay, so let me just one more time revise this topic. So this is principal component analysis, PCA. Why we use it? If we have too much data, about the customer or anyone like this. If we have too much data, then we have to plot many charts, 5 to 10 charts, to make sense out of it. But what this PCA technique will do is reduce them automatically to two-dimensional or 2D data and plot this chart. And in this chart, same dot means these customers have same kind of characteristics, and if the dots are nearby, then means these customers have something in common. If they are there is big difference between or space between them, this means these customers must be having some difference in their characteristics. So similar characteristics, different characteristics, and due to k-means clustering, these dots are different colored. So yellow, 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 yellow means they fall in same clusters. These customers must be having something in common. So this is the thing. This is how you read the PCA chart. This is how you read PCA. So let's see this. I have included the data.csv also here. You can copy this. This is the data. Then this is the program file. Okay, and I have also included the final output also. So this is the figure, and this is called scatter plot. Yeah, one more thing, I have not shown the code here. So this is the code. This is the code. This is how you use PCA to reduce it to two dimension. This is what you have to pass the dimensions, n underscore components equals to 2. This is how it will automatically do the things. This is PCA, and you have to read the CSV file like this, and it contains this data. I will continue this session in next video. See you in next video. Have a nice day.